Welcome back to Logic Basics. We are entering into what will become a section on formal logic. There are two handouts we're going to go over. One is what are judgments? That's what we'll do right now. And then after this, what are arguments? But we're going to go back. So we're going to look at what are judgments, and then we're going to go into how to use the square of opposition to determine the truth, falsehood, or doubtfulness of a judgment. So anticipate learning about the square of opposition when we do judgments, but I'm going to give you an overview of arguments before we get to the section on arguments. So we will spend a few sessions on judgments, but I'm going to introduce you to arguments before we get to the session on arguments, just so you know where we're going. And the handout I've given to you, let me go there, on what are judgments, has some quotes from a little book I want to show you. Maybe I should make this big again. This book is called Basic Logic by Raymond Mccall. This book is out of print. Otherwise, I would have used it for class. You may be able to find it on Amazon or at a used bookstore I got mine for like $1. But I do use some of the exercises from this book, and so some of the handouts that are coming up are either photocopied from the back of this book or are typed up from this book. And just to anticipate, those handouts aren't so beautiful, but I'll do my best. So let's talk about judgments. Remember, Aristotle talked about 3 acts of the mind. The first act of the mind is concept formation. So judgments, the second act of the mind, or the second act of reason. After we form concepts, we make judgments. And then after we make judgments, we make arguments. So concepts, judgments, arguments. More basic, less basic. So concepts were the more basic. We spent a lot of time talking about concepts. Now we're going to briefly go over judgments, and then we're going to start working with judgments. And this is where we're going to do logic. And this is going to be a lot of learning by doing, and it may be painful. You will learn to do logic by making mistakes. And so I give you permission to make mistakes in your practicing, and it's okay to fall down. It's okay to go, I have no idea what we're doing right now. Feel free to email me questions, and feel free to watch these videos several times if you have to. And read the textbook that goes along. Remember the Peter Kreeft book? I have readings from that book also. You can get the Mccall book as well. So there are lots of resources out there. And remember, logic, formal logic is formal logic. You can Google this stuff too and find other videos on YouTube if you need to. So let's talk about judgments. A judgment is 2 concepts joined together by affirmation, is, or separated by negation, is not. So the book is on the table. The book is not on the floor. These are judgments. Sometimes people think judgments are bad. Judgments are inescapable. They are an act of the mind, and they're the way we say X is Y. So I think when people say judgments are bad, I think they mean something different, like judging people, like saying that person is ugly. That may be making a judgment that is unsubstantiated, relative, a matter of taste. So those are different than what we're doing here. They do take the same form, but they may not be rational judgments. It may be judgments of taste, like onions are evil. You guys might like onions. I don't like them, but that's not what we're talking about here. We're talking about a judgment having a subject term, the first concept before the is, a copula, which is the is or the is not, and a predicate term, the P term. So a judgment has 3 terms: the subject term, S term, the copula, we'll call it C, and the P term, the predicate term. So the subject comes before is, the predicate comes after is, or is not. All right, so here's some quotes from the basic logic book that I just showed you. To judge is to think in the full and proper sense, so that when we define logic as the art and science of right thinking, we might just as properly say the art and science of right judgment. So logic wants to help us to make right judgments. Right thinking is right judgments. Judge things properly. Okay, a little bit about the subject and the predicate now. The subject is that about which I am affirming or denying something. The predicate is what I affirm or deny about it. The dog is brown. Okay, so the dog is about which I'm affirming or denying its brownness. Okay, the predicate is brown. Judgments are either true or false and are expressed by propositions. So judgments and propositions are slightly different. We're going to look at different kinds of propositions. Now we're getting into the formal aspect of logic. Propositions may be classified as either categorical or hypothetical. Aristotle gave us categorical propositions, categorical statements. And hypothetical comes later in the history of logic because later philosophers saw, hey, wait, sometimes we make judgments that aren't categorical. So we are going to learn the distinction between categorical or compound hypothetical syllogisms, judgments, and then syllogisms later. Differences in these propositions is based upon differences in the copula. Remember, is not. A categorical proposition uses a verb, is not, are not, to unite subject and predicate, while the hypothetical proposition uses a non-verb copula, and, or. So we'll learn those later after we go through the categorical propositions. So we're going to focus now on Aristotelian logic, Aristotelian categorical statements or propositions. So here's a tool that we're going to learn. I'll put it up first so you can see it. This is called the square of opposition. I introduced it to you earlier, but now we get to see what it's used for and how we can use the square to determine whether a statement is true or false or doubtful. All right, let me go back to the 4 forms of categorical propositions. So there are 4. We see them here on the corners. And I want you to learn this. I want you to know this. This is going to be an integral part of the rest of our study. Put it on a note card. Put it in your long-term memory. You need to know this. All right, so all S is P is like all apples are red. Okay? All apples, every single one of them. When we say all, this is a universal claim. All is a universal, every single one of them. And when we say is, all is, in this context, it's affirming. So all apples are red. Now that would go over here on this corner. So we could put in S, apples, and red for P, okay? So all apples are red. Imagine that. Maybe even write this down in your notes. When you have the handout in front of you, write all apples are red under this corner here. That's called the A statement. It's got a name, okay? All SSP is A. You need to know that, okay, forever. All SSP is the A statement. Next we have no S is P. No S is P goes here on the square. No apples are red. Okay, no apples is a universal again. It's saying not even one, none. And it's a negative. Now this is going to be a little bit tricky because the negative is not in the copula for the E. This is an E statement. E goes here. No S is P is an E statement. And it's saying no apples are red. There's our example. Now, that's a universal. So notice the universals are up here on the top. All and no are both universals. This one affirms is, this one negates not. Now, we're going to go down to the bottom here, and we have some S is P, some apples are red. That would go here on the square. And this is a particular affirmative. Particular means at least one. So when you say some SSP, you're saying at least one apple is red. At least one apple is red. And it's affirming again. It's saying it is red. And this is called the I statement. So some SSP is I. So A, E, I. And the one that's left is some S is not P. This is the O. This is the O corner, and that's down here. Some S is not P. And this is called a particular negative. At least one apple is not red. Some apple is not red. Okay, so this is a particular negative. Some is not. And this is called an O. And I was just reminded that there are other versions of the O that I need to tell you about. I am actually going to pause for a second and look inside this book to give you what are called the tricky O's. And you know what? I'm going to actually pause the recording and get the Kreeft book too. I'm going to show you the page about the tricky O's, because O has different versions and they will trick you. So I have to tell you about that. Hang on just a second. Okay, I'm back. I paused for a moment to do a couple of things. I want to give you a page number in the Peter Kreeft book where you could read about the tricky O. He talks about judgments in the section starting on page 148, but on page 151 he talks about the tricky O, and he calls it the tricky O. And he gives you examples. Let me just read this to you. He says, in the English language, all S is not P is ambiguous. Remember, words can be ambiguous, meaning can be ambiguous. It has two very different meanings. Only one of these two meanings is that of an E proposition, that every S fails to be P. The other meaning of all S is not P is very strangely that some S is not P. In the ordinary English that we all speak every day without thinking about it, all S is not P often means some S is not P. Okay, so another way of thinking about this is that when you see a statement that looks like this, no S is P, it's an E statement. E always says never S is P, no S is P. But when you have a sum or particularity, a sign of particularity with a negative is not, then it's an O. Now Mccall also talks about this, remember this book, and he talks about it on page 53 if you have this little book. He says this: note and note carefully that the proper form of the true universal negative, which is E, is not every S is not P, but is no S is P. So every time the E is going to say no S is P. There is no exception to this rule. Note also the many forms of the particular negative or O proposition, of which every S is not P is one example. So what I've done is I've made a list of them for you over here. I've made a little list of the regular O. Here's what the regular O, the particular negative, I should type that really quick. This is a particular negative statement. And let's put that in brackets. So the O is some S is not P, but here's a short list of the tricky O. And both books have these listed, tricky O. Sometimes the O looks like this. Not every S is P. But notice we have not every is at least one, and it's negative. So we have, again, a particular negative. That's how we know it's an O. It's not a universal negative. It's a particular. Not all is particular, and not has a negative. So the not and the is are not together, but they're implied together. Every S is not, the is not is negative, but this is saying every. But if you have an every and it is not, it's a particular. I'll show you an example. And then all S is not. Again, it's a universal. So the only difference between not every and not all is that the word every and all. Both are universal, but they're with a negative. Again, here, every and all, both are universal, but they're with a negative. Let me give you an example, because I know students really struggle with this one. This may be one where you have to get tricked to learn it, and that's okay. You can get tricked by the tricky, I'm going to put my books over here, and I'm going to give you an example. Here's an example from, I think, the Mccall book. Every dog is not vicious. Okay, so that's saying not all dogs are vicious, right? So here's an example. Kino, who's here on the floor, Kino is a dog, and Kino is not vicious. So some dogs are not vicious. So you can see from this example, no, every dog is not vicious is the same as some dog is not vicious. At least one dog, and I have him. He's in this room right now. Go through the same these other examples with the same words. Not every dog is vicious. Not all dogs are vicious. Every dog is not vicious. All dogs are not vicious. They mean the same thing. Okay, so here's an example of the tricky O. You will encounter the tricky O. You will get tricked by it, and that's okay. So I'm spending a lot of time on this because we're going to be doing some exercises, and the tricky O will come up, and I want you to be able to identify it. All right, I'm going to go back to our handout over here, and so the tricky O's fall under the O corner of the square of opposition. All right, now how do we use this square? What are the rules for the square? You know what, maybe I should pause here so that we could take a little breather, take in what we've learned, and then we'll go into the rules of the square in the next video. So what we've learned so far are, let me go down here, I have some questions. We have learned about what a judgment is. We have learned about the 4 basic forms of categorical propositions, A, E, I, and O. And what are A, E, I, and O again? Right here. A, E, I, and O. So I want you to learn this, know this, put it on a card, note card, memorize it, know it for the rest of your life, because then you can identify what kinds of judgments are being made. Okay, I'm going to pause, and we're going to come back and talk about the square of opposition and the rules for the square. How does it work? What do we do with it? All right, it's going to be exciting.